as we discussed, the rate of change is one of the application of the differentiation. If dy by dt is calculated, it shows us the rate of change of y with respect to t. Now let's discuss some example. Let us say the length of a rectangle is increasing at the rate of 3 centimeter per second and the width is decreasing at the rate of 3 centimeter per second. So in this question we know that the dl by dt, that is the rate at which the length is increasing, is 3 centimeter per second, but the rate at which its width is decreasing is also 3 centimeter per second, but because it is decreasing, so it is negative 3 centimeter per second. Now we have to find the rate of change of the perimeter and the area at the instance when the length is 14 and the width is 6. So let's note those values down. Length is 40 centimeter at that instant and the width is 6 centimeter at that instant. The perimeter of a rectangle is 2 times length plus width. So the rate at which the perimeter will be changing is given by twice of dl by dt plus dw by dt. So if we plug in the appropriate values, the answer will be twice of 3 minus 3, which is 0. So there is no net change in the perimeter at any instant. Now take area. The area of a rectangle is length times width. So if we differentiate area with respect to time, we will get dA by dt. And applying the product rule on the left hand side, it will be W times dL by dt plus L times dW by dt. At the instant when the length is 14 centimeter, width is 6 centimeter, and dL by dt is plus 3 and dW by dt is negative 3, the rate of change of area, that is dA by dt, is 6 into 3 plus 14 into negative 3. It will be 18 minus 42, that is negative 24 centimeter square per second. Now if we add another problem to the same question, the rate at which the diagonal of the rectangle is changing, it can be calculated. First of all, the relationship of the diagonal with length and width is that d square is L square plus W square, which is known by Pythagoras theorem. Because if the diagonal of the rectangle is d and the length is W and width is length is L, sorry, and width is W, and this is a right angle triangle, so obviously applying the Pythagoras theorem will generate this relationship. Now on differentiating this with respect to t will give me 2d dl by dt, sorry, 2d d of diagonal by dt equals to 2l dl by dt plus 2w dw by dt. This 2 can be cancelled throughout. So the rate at which the diagonal is changing is d times the rate of change of diagonal equals to L times dl by dt plus w times dw by dt. So we also need to know the value of diagonal when length was 14 and width is 6. So it means that the diagonal is the square root of sum of squares of 14 and 6, which is going to be square root of 232, and it may further simplify to 2 root 58 centimeter. Hence dd by dt is equals to 14 into 3 plus 6 into minus 3 divided by 2 root 58. On simplification, it would become 42 minus 18 over 2 root 58, which is finally equals to 12 over root 58 centimeter per second. Now let us discuss another example where a 25 foot ladder is leaning against a wall and is sliding towards the floor. If the foot of the ladder is sliding away from the base of the wall at the rate of 1.5 feet per second, how fast is the top of the ladder sliding down the wall when the top of the ladder is 7 feet from the ground? If we want to solve this problem, let's first of all draw a figure which would represent this situation. Suppose this is the wall, this is the floor, and a ladder may be this. The ladder is sliding away from the base of the wall and hence its height is also reducing. The rate at which it is getting sliding away is given as 1.5 feet per second. So we get to know the rate at which the height is decreasing. Let's say the height is represented by y and the rate at which it is sliding away, this the side is known by x. So dx by dt is 1.5 feet per second, and we need to know dy by dt, and it is at the instant when the top of the ladder is 7 feet from the ground. So at y equals to 7 feet, and it is known that the length of this ladder is 25 foot. Applying the Pythagoras theorem here, x square plus y square should be equals to L square at all the moments the ladder is leaning against the wall. So the value of x is simply L square minus y square square root. It's going to be 25 square minus 7 square at that moment. That is going to be square root 576, which is equal to 25 foot. Now the relationship is simply x square plus y square equals to L square, but this relationship is not sufficient to solve the rate at which the length, this rate of x, decrement of x. But now differentiating this relationship, both sides, gives us 2x dx by dt plus 2y dy by dt equals to 0. That is because L always remains constant while x and y are changing variables. So a little algebra helps us to know that dx by dt is going to be minus y over x times dy by dt. So at the given instant, the, there is a little correction there. We need to find dy by dt. So this relationship should be corrected, and dy by dt hence is equals to negative x over y dx by dt. So at that moment, the answer comes out to be minus 24 over 7 times 1.5, which is going to be negative 36 over 7 foot per second.